the water vents were calculated?
So actually before this, I was not very clear about this, but because I did this before the conference, right? So yesterday after I heard like the talk from Dr. Harpreet, I found that I could improve more in this part. So yeah.
So yeah. Harpreet, thank you for the presentation yesterday then. Good.
Thank you.
Any other questions? Okay. So Anis, please just stay here. We will continue later for more discussion. So our next two presenters are coming from one of the sponsors of the big sponsors of this conference, and our collaborator and supporter over many years. The presenters are coming from the aquaphotomics lab developed by UNOSATO, our sponsors, and they will present some of the experiments that they performed in relation to the production of UNOSATO's products. So first is who is presenting is Ryo Takagi. He's going to be presenting something about the influence of sound. Ryo?
Hello.
Hello, Ryo. Nice to see you.
Yeah, nice to see you. Can you hear me?
Yes, yes. Can you share your screen?
Yes.
So you have 10 minutes.
Okay. Hello, I'm Ryo Takagi from UNOSATO Aquaphotomics Lab. Today I'm going to talk about who we are and our recent project. And there are three different types of well water at our facility. Three different types of well water at our facility: gold water, silver water, and bronze water. These waters have differing functions and effects and have tested various kinds of blend ratios. As a result, in 1995, Tsuki no Shizuku, meaning moon drops, was produced. And we have received many positive evaluations from our customers, as well as from multiple industries. However, looking at the substances couldn't scientifically explain the improvements customers were speaking of. Since Professor Tsenkova visited our facility in 2005, collaborative research in aquaphotomics began. Until today, we have been researching our three waters, developing new products, and publishing academic papers utilizing aquaphotomics. And we have specifically focused on application in agriculture sector, as Professor Tsenkova continued her research at Department of Agriculture. We have big natural farming sites where we don't use any fertilizer, and also have 1,000 square meter hydroponic farm. In those facilities, we grow agrochemical-free crops throughout the year using our water. In December 2020, the world's first aquaphotomics lab was constructed, housing leading-edge technology and equipment. And along with the start of our new lab, I developed a new flowing water device and cuvette holder. My idea was to modify post-dispersive spectroscopy, modifying the Hamamatsu Photonics fixed cuvette holder to a flowing water cuvette model. And this is a cuvette holder, and it can be separated and into two parts, and the flowing cuvette cell is placed inside. They are combined in this way, and with this flowing model, we can continuously measure the sample without having to reset the cuvette into the holder for each measurement. This allows for increased efficiency as well as accuracy with less external factors to influence the measurement, as the cuvette is removed and replaced. Water pressure and speed were adjusted to be constant using this Marriott bottle, and therefore the effects of the entrance light on the sample are limited and consistent. For example, with this flowing method, gold water was measured for 5 minutes, collecting 100 spectra, resulting in PCA factor 1 ratio of 99.99999%. We can confirm that extremely consistent spectra can be obtained with less noise. On the other hand, because it is so consistent, perturbation changes on the water by external factors during the experiment can be measured very accurately. Therefore, as the first experiment with the flowing water device, I chose sound frequency as the perturbation. For many years in the music history, 432 Hz was one of the fundamental tones. However, in 1953, it was authorized to 440 Hz, formerly by ISO. I wonder if 8 Hz difference has an impact on water. And in the past, just temperament was used in music in which the frequency of the chord becomes a simple integral multiple. But in our days, the equal temperament is used where all scales are equally divided and the same root figure is and is not divisible. In this study, one type of water, gold water, underground water from Yunosato was used. During the experiment, two specific frequencies, 440 Hz and 432 Hz, were applied to the flowing water. Each frequency was turned on and off alternately for 1 minute each, in total for 10 minutes, while 15 spectra were obtained per minute. Here, objective variables are assigned as 0 for sound off and 1 for sound on. The results for 440 Hz, the PRSDA model of the spectral data was well fitted. The left two figures were very fitted, where 432 Hz fitting ratio was lower. 440 Hz seemed to affect water in a more consistent pattern compared to 432 Hz. And this is different spectral analysis of averaged samples. 440 Hz sound spectrum minus no sound state spectrum. Subtracted spectra from 3 experimental days in similar conditions and procedure showed common peaks, especially in small water cluster region. Interestingly, sound doesn't affect the big hydrogen bounded change as usually seen in many aquaphotomics studies. And I conducted further experiment with the 2 chords here, 432 Hz based just temperament, which is divisible, used for tuning of instrument in ancient time, and 440 Hz based equal temperament, which is not divisible, used in modern time. In the results of the Y-fit, the PS model of 440 Hz with equal temperament chords showed a high fitting ratio, whereas 432 Hz with just tempered chord doesn't fit to the model. I further conducted experiment. I first measured flowing water without sound consecutively 40 times, and then 80 times with respective frequencies, and repeated 3 times each. I made a PLS model where objective variables were assigned as 0 for sound off and consecutive numbers for sound on. With 440 Hz, these 3 figures, there are several visible gaps through the time series PLS score plot. But with 432 Hz, continuous waving change can be observed through 3 experiments. And when we see the regression vector of the 3 experiments, with 440 Hz chord, similar patterns were observed through the experiments, especially in the small water cluster region. But with 432 Hz, regression vectors pattern were different through the experiments, lacking consistency. As I confirmed in the first experiment, 440 Hz based equal temperament chords affect the water in a consistent pattern, where the frequency is when the frequency is applied, But while 432 Hz-based just temperament code tend to affect water differently. And another trial was I modified CNN, a convolutional neural network, picture classification program of the Python for the spectral classification. Using experiments of the 440 Hz on and off, total 300 spectrums, I tried to classify them into two groups of spectra. In CNN, the picture's distinctive characters are assembled, gathered in neural network, and finally classified. This result shows that conventional multivariative analysis like PSDA or SIMCA had maximum of 90% accuracy, whereas with five-fold cross-validation, CNN accuracy rate increased to 98.3%. This result suggests that deep learning can be used for spectral analysis and for classification. The correlation between explanatory and objective variables has long been a black box, but now gradually uncovered thanks to all the researchers done worldwide. Next, agricultural research we've been working on.
You
I
have
also
to,
presented
you have
in
to
the
finish.
last agrophotonics conference, where I made two pairs model for the freshness and temperature of healthy basal leaves. We can regard those models as a representation of healthy bioreaction towards outer factors. When the models are applied to mold leaves, they are scattered and out of program. In this way, the leaves reaction
Ryo.
towards outer factors
Ryo, please.
used for quality assessment.
Ryo, Takagi-san,
With
you
the
have to.
newly equipped vacuum dryer in the lab, we started experiments.
Ryo-san, you have to finish in 1 minute.
Okay. With the newly equipped vacuum dryer in our lab, we started experiment with biofunctional water, which is extracted from our naturally farmed vegetables to develop new products. This is a raw spectrum averaged biofunctional water spectra of 3 crops type. And this right one is the raw spectra of 3 raw vegetables. A similar hydrogen bonding pattern can be seen between raw vegetables and biofunctional water. So with newly constructed facilities and cutting-edge devices, our new journey has just begun. Together with the guidance of Professor Tenkova, the 6 lab members will continue to explore the world of water through aquaphotonics. And by developing new products, we would like to promote a happy and healthy life for all. Thank you very much.
Thank you, Ryo. I'm sorry I had to cut you short. Please stay here for the questions after post-session because we ran out of time currently. We will have more time later. Now from the Unisato Aquaphotonics Lab, another presenter is going to speak actually more about this biofunctional water. Alexander Stoilov, Boyko Stoilov, are you here? I see the hand.
Yes. Oh, sorry. Okay. I'm sorry. Okay. Hello.
Hello, Alex.
Share the screen.
So 10 minutes.
Yes, just give me a second.